name is Renjith. Today I am here to teach you mathematics, and we'll be discussing on the topic relations and functions. We are all familiar with a wide variety of relations that exist in our society, like father and son, teacher and student. Another example, brother and sister. What are all these? All these are just relations, and we are all familiar with it too. In the same manner, in mathematics too, we have a wide variety of relations. For example, line L1 is parallel to line L2. Another example, a number x is greater than a number y. In the same manner, we do have a lot of relations that exist in mathematics, which are quite familiar in the number systems too. Now, this relations, the term relations, has been derived from the literal meaning from its English version, or the word is being drawn from the English literary meaning. Thus, the concept of relation is very closely related to the concept of the word relations in an English language. Now let's move on to the short answer type question that carries 2 marks. Now the question here is, let A be the set containing the elements 1, 2 and B be the set containing the elements 1, 3. What? Oh, I forgot to place the elements. Okay, there you go. Okay, let's come back to the question. Now, again, A is a set containing the elements 1, 2 and B is the set containing the elements 1, 3. Now, the relation R is defined here from set A to set B such that R is equal to set ordered pair 1, 1, ordered pair 1, 3, ordered pair 2, 1 and the ordered pair 2, 3. Now the question here is, listen carefully, is R a universal relation? You have heard the word universal relation, right? Now what is a universal relation? Before going deep into the question, let me brief on what a universal relation is. Now, a universal relation, every set containing a relation R, let it be a relation R in set A in general. A relation R in a set A is called a universal relation only if each and every element of the set A is related to every element of the same set A. That is, the relation R should be equal to the Cartesian product of A and A. That is, R is equal to A cross A. That is called a universal relation. Now, coming back to the question, here, how can we prove that the given relation is universal? First, look at the relation. R gives the ordered pairs 1, 1, 1, 3, 2, 1 and 2, 3. So if R has to be a universal relation, we should prove that the Cartesian product of A cross B should also be the same set of ordered pairs as contained in R. So here we are having the sets A and B. A is a set containing the elements 1 and 2. B is a set containing the elements 1 and 3. Now here, let us take the cross products of A and B, that is A cross B. The first ordered pair would be 1 related to 1. That is, the first ordered pair, the first element from A, that is 1, and the first element from B, that is again 1, thus getting the ordered pair 1, 1. The second ordered pair would be the first element from A, that is again 1, and the second element from B, that is 3. So the second ordered pair would be 1, 3. Now the third ordered pair, and the second element from A, that is 2. Now the first element from B, that is 1. Thus the ordered pair 2, 1 is formed. Now the last and the final ordered pair possible from the two given sets is that the second element from A, that is 2, and the last element from B, that is 3, thus constituting the ordered pair 2, 3. Thus we have in the cross product A cross B giving the set of ordered pairs 1, 1, 1, 3, 2, 1 and 2, 3. Just look at these pairs of ordered pairs. What is it? The relation R as well as the cross product A cross B are both looking the same, exactly the same. So R is equal to A cross B. Thus, we have proved that R is a universal relation. Whenever you hear the terms universal relation, the first thing that should rush to your mind should be the equation R is equal to A cross A. Though in general we say that the equation is R is equal to A cross A, it could be replaced with any sets as given in the question. So don't get confused. Now you have scored 2 marks. Now let's move on to the long answer type questions. The question is this: show that the relation R defined in the set A of all triangles as R is equal to set T1, T2 ordered pair such that T1 is congruent to T2 is an equivalence relation. Now the question is this: show that the relation is an equivalence relation. To prove that the given relation is an equivalence relation, we must first prove that the relation R is reflexive, symmetric, and transitive. Now let's deal with the three in detail. Taking the first relation, the reflexive relation. We know that any relation R in a set A can be called as a reflexive relation if ordered pair A, A is an element of R. That is, the ordered pair A, A is an element of R. Now to show that the given relation R is reflexive, we must prove that the ordered pair T1, T1 is an element of R. That is, the ordered pair triangle 1, triangle 1 is an element of R. We know that it is quite familiar that every triangle is always congruent to itself, and that is a fact. Now consider the triangle 1. This triangle 1 is congruent to the same triangle 1, and that is a fact. Now if triangle 1 is congruent to triangle 1, then we can say that T1, T1, the ordered pair T1, T1 is an element of R. Thus we prove that R is reflexive. Now let's consider the second type of relation, that is the symmetric relation. For any relation R in a set A can be called as a symmetric relation if ordered pair A, B element of R, then there exists an ordered pair B, A which is also an element of R. Now in this case, to prove that the given relation R is symmetric, we must prove that if T1, T2, the ordered pair T1, T2 element of R, then there exists an ordered pair T2, T1 which is also an element of R. So how do we prove that? We know that in a triangle, if triangle 1 is congruent to triangle 2, then we can say that the triangle 2 is also congruent to triangle 1, right? So here it is given that if T1, T2, the ordered pair T1, T2, if that is an element of R, according to the given relation, it means that triangle 1 is congruent to triangle 2. That means triangle 2 is also congruent to triangle 1. Thus, T2, T1 is also an element of R. Thus, the given relation R is symmetric. Now let's consider the last type of relation, that is the transitive relation. For any relation R in a set A to be called as a transitive relation, it should satisfy the condition that if the ordered pair AB element of R and the ordered pair BC element of R, then the ordered pair AC would also be an element of R. Now coming to this problem, here to prove that the given relation R is transitive, we must prove that if T1, T2 element of R and T2 comma T3 element of R, then there exists an ordered pair T1 comma T3 which is also an element of R. Only then the relation R can be called as a transitive relation. So we know that here if T1 comma T2, the ordered pair T1 comma T2 is element of R, then triangle 1 is congruent to triangle 2. Also, if T2 comma T3 is element of R, then we know that triangle 2 is congruent to triangle 3. That means that it is very clear that the second triangle, triangle 2, is congruent to both triangle 1 and triangle 3. Thus, it is proved that all the three triangles are congruent to each other. So, it is natural that we can say that triangle 1 is congruent to triangle 3. Thus, T1, T3, the ordered pair T1, T3 is also an element of R. That means that the given relation R has become transitive. So far we have discussed and proved that the given relation R is a reflexive, symmetric and transitive relation. Thus, the given relation R can be called as an equivalence relation.
How much have you secured now? You have got 6 marks.
The only way to learn mathematics is to do mathematics. So do the best and you will get the best. Let me sign off for now. Bye-bye.